Hey guys, welcome to another lecture from EcoPoint. And from today, let's start revising the key concepts in maths that you should be very well aware of, thoroughly aware of, in case you are sitting for CUET PG entrance exam and other exams associated to PG Economics. Okay, so I'm starting off with functions and its type. So let's quickly brush up what exactly is a function. So let's define what a function is. So function is a mapping, okay? It is a map. A function f from A to B maps elements from A, each element from A maps each element from A from the set A, which we call domain, to exactly one element, one unique element in the set B. The set B is called the codomain, and the set of all images, that is the set of all fx's, is called the range. So you need to know these two terminologies, domain and range. In order to understand, the notation is y equals to fx, within which y is called image. Image of what? Image of x. X is called pre-image. So what is domain? Domain is the set of pre-images. And what is range? Range is the set of images. These are the two most important things that you should remember. Notation, as I've mentioned, you have y equals to fx. In case f is a function, then each x has a unique y for it. Well, you can have varied type of functions. You can have functions with function that looks just like x. This is a function. This is a function where x is giving x only. So 1 gives out 1, 2 gives out 2, so on and so forth. And you will be able to use all real numbers and generate all real numbers. You can have a function which is x square. So what will happen? You put an x. For every x, you will get a unique y. You can have x cube. You can have x cube minus x cube plus x, so on and so forth. But all these functions are, they're individually different type of functions. In the first example, x is to the power 1, which is an odd power. In the next one, it is an even power. In the next one, it is cube. So it is an odd power and so on. So you can have different types of functions. And here, let's broadly divide functions into the following parts. So 1 to 1. We call 1-1 or 1-to-1 functions. 1-to-1 functions are also known as injective functions. An injective function basically means that if you have the same image, it has to come from the same pre-image. 1-to-1. One particular x has one particular y. One particular x has one particular y. Just like you have 1-to-1 function, you can also have something called many-to-one. Now, a many-to-one function basically means you have multiple inputs mapping to or maps to the same output. So you have, say, you have x1 and x2, both are mapping to the same y. For example, think about it. For example, x square. So whether you have minus 2 or whether you have 2, both will give you 4 because squaring will take away the negative sign. So you will get 4 in both the cases. That's a many to one function. What a function that is many to one can of course not be one to one. Then you also have something called onto. Onto is also known as surjective. Now, what is a surjective function? A surjective function is where your range is equal to the codomain. Where range is equal to the codomain. So, in types of function, what have we mentioned? One-to-one, where distinct elements in the domain are mapping to distinct elements in the codomain. Many-to-one, multiple inputs, just single output. Onto, that means range is equal to the codomain. Okay. Now, what you need to understand is there could be functions which are many to one, there could be functions which are one to one, there could be functions which are one to one and onto, there could be functions which are one to one but not onto but not one, and so on. Let's look at some complicated questions and understand how to figure out whether a given question, whether a given function is one to one, onto. Let's look at fx equals to x cube minus 3x plus 2. Let's check whether this function is one to one, whether this function is onto. Okay. Now, when nothing is provided to you about your a and b, always assume that the function is a real function. That is, it's from R to R. The possible inputs are real number, the possible outputs are also real. Now, for injectivity, what to do? For injectivity, there could be different ways of working it out. Now, one particular way, whenever you have a polynomial or a differentiable function, just differentiate it. Find f dash x. Now, once you find f dash x, you will get, okay, it is 3x square minus 3. In other words, I can say that it's 3 times x square minus 1. I can take 3 common, right? If you observe the critical points here, the critical points, this is equal to 0. That means x is equal to plus minus 1. X is equal to plus minus 1, right? Now let's evaluate f dash x. F dash x, which is 3 times x square minus 1. This expression will be greater than 0 in case x square is greater than 1. That is, whenever x is either less than minus 1 or greater than 1. Then, this expression will be positive. And on the other hand, when x square minus 1 is less than 0, this expression is less than 0. That is, whenever x is between minus 1 and 1, it is less than 0. So what's happening is, here it is increasing, and here it is decreasing. So what is happening is that it increases when x is less than minus 1, it increases. Then between minus 1 and 1, it decreases, and then again it increases. In this process, what's going to happen is, as you can see here, there could be a place where two x's are giving you the same y. And this is called the horizontal line test. If you're able to graph a particular function, you can use horizontal line in order to check whether the function is one to one or not. So horizontal line test tells you that in case you create a horizontal line cutting the graph and it cuts the graph at more than one point, that means there are multiple x's fetching you the same y. Another way how you can deal with polynomials is that try to look for the roots. Let's see if we are able to. Well, if I put x as 0, let's try hit and try. At 0, this function is giving me 2. So that's not the root, right? If I put 1, what am I getting? I'm getting 1 minus 3 plus 2. And that gives you minus 2 plus 2, that is 0. So 1 is one of the roots. So in case 1 is one of the roots, that means I can say that x cubed minus 3x plus 2 is equal to x minus 1 into some other polynomial gx, and we can find this gx by dividing x cubed minus 3x plus 2 divided by x minus 1. So what am I going to get? Well, to get x cubed, x square is required. So x cubed, and here I will get minus x square. Well, if I subtract, this goes off, and minus minus makes it x square as it is, and from here I'm going to get minus 3x, right? Now, in order to get x square, I'm going to multiply by x. So plus x there, and that gives me x square minus x, whole thing upon whole thing. I'll subtract. I'm going to get this. This turns into plus. So this is minus 2x plus 2. And in order to get minus 2x, I'm going to take minus 2. So that gives me minus 2x, and multiplying that here gives me plus 2. And now when I subtract, this entire thing cancels off and I have a remainder of 0. So which means I can say that x cube minus 3x plus 2 could be factorized as x minus 1 into x square plus x minus 2. Now x minus 1 multiplied by, can we factorize this? Let's see. Minus 2. So 2 and 1. So x square plus 2 x minus 2. And that will give you the following factors: x plus 2, x minus 1. Right? So this basically polynomial is x minus 1 square x plus. So how is this helping me? This is helping me in order to prove that this function is not 1, 1. It is not 1 to 1, and I have been able to prove it through this because I am getting two roots. So I know that f of 1 is 0 and also f of minus 2 is 0. F of minus 2 is also 0. So therefore, you have figured out one example where 1 and minus 2 both are giving you 0. That means it's a many to 1 function. Now, if I want to figure out whether this is an onto function or not, for onto, what do I require? I require range to be equal to the codomain. Since I did not provide you with anything, I asked you to assume it to be an R to R function. So that means the codomain is R. What about the range for this function? How will you figure out the range? You just saw that this function is increasing, then decreasing, then increasing. It's increasing, decreasing, then increasing, right? That is the first thing that you realize in here. Second thing that you realize about this function: fx is x cube minus 3x plus 2. It's a polynomial. All polynomials are continuous. It's a continuous function. When a function is continuous, it basically means that it is generating values for all inputs. There is no break in this function. So there is no break in this function. There is no break in this function. This function will have its minimum and maximum. And range is nothing but the set of all images, the set of all fx's. Now all the fx's will lie between the minimum of the f and the maximum of the f. So is it possible to find the minimum and maximum? It's a polynomial. It's very easy to find minimum, maximum. Actually, since x goes from x belongs to minus infinity to infinity, right? So x would be tending towards minus infinity. Look at x cube minus 3x plus 2. Can you see that when as x is tending towards minus infinity, x cube minus 3x plus 2 will also go to minus infinity because it's an odd power. Can you see odd power, odd power? So you will be generating minus infinity only. And as x is tending towards plus infinity, x cube minus 3x plus 2, since x is going to plus infinity, this entire expression will also go to plus infinity. And this actually, see, it also comes from the fact that your function is something of this sort. It looks like this. So it's coming from minus infinity and then going to plus infinity. But of course, I don't assume you to be, able to create a graph out of it every time. Okay, I used a software and quickly I gave you the graph. Sometimes you will be able to graph certain functions, sometimes you won't be able to. So I want you to think logically out here. This is how you can evaluate that the range actually has to be minus infinity to infinity. That is basically R, and which is equal to the codomain. So therefore, this function is not one-to-one, but is this function onto? The answer is yes, this function is surjective. Now, what I would like you guys to do, practice yourself. Let me give you a question. Practice fx is equal to e to the power x plus x. Is this function injective? Is this function onto? Whatever input that you have got from this question, from this lecture, use everything and try to find it out. And do mention it in the comments what the answer should be. So from what we have discussed today, I would like you guys to keep the key points with you. In order to check for injective functions, there are two things that you should use. You should use derivatives, or you can also use the horizontal line test. Okay. And for checking onto, the analysis that you should use is the limit analysis. Or in case you have closed domains, then of course, maxima, think in terms of max min. And you will be able to figure out the range easily. And hence you'll be able to comment on whether the function is onto or not. I hope this lecture will really help you out in revising the few important concepts in functions. I'll see you in the next one with some more concepts and examples. Thank you very much. All the best, all the time.